Have you ever wondered how the world might meet its end? Today, we're embarking on a journey, exploring 8 scientifically plausible, yet extraordinary natural phenomena that could potentially signal the end of our world. Let's delve into the least devastating yet still extraordinary natural phenomenon that could mark the end of our world. At number 8, we have solar flares. Imagine the sun, our familiar celestial neighbor, suddenly becoming a source of chaos. Solar flares are like massive explosions on the sun's surface, hurling a surge of radiation and charged particles into space. These flares, when they reach Earth, could potentially cause significant damage. The radiation from these flares can interfere with our satellite systems, disrupting communication and navigation. But it doesn't stop there. A powerful solar flare could induce currents in our power lines, leading to widespread power outages. Picture a world plunged into darkness, with no electricity to power our homes, our hospitals, our cities. But it's not all doom and gloom. These solar flares serve as a reminder of our connection to the cosmos and the delicate balance that allows life to thrive on Earth. While our world would not cease to exist, life as we know it could drastically change. Moving on to number 7, we have the threat of an asteroid impact. Throughout the history of our planet, asteroids have left their mark, sometimes with cataclysmic results. You've likely heard of the asteroid that ended the reign of the dinosaurs some 65 million years ago. This cosmic missile, estimated to be about 6 miles wide, slammed into Earth, triggering a series of catastrophic events including firestorms, tsunamis, and a nuclear winter effect that blocked out the sun. But that was then. What about now? Well, space is full of these rocky time bombs, and it's just a matter of time before another one sets its sights on our planet. The result? Depending on the size and speed, the impact could trigger global fires, tsunamis, and potentially a long-lasting winter. The aftermath would be devastating, disrupting ecosystems and potentially causing mass extinctions. The impact of a sizable asteroid could very well mean the end of most life on Earth. At number 6, we have the eruption of a supervolcano. Imagine a volcanic eruption so powerful that it dwarfs every eruption in human history. That's a supervolcano. These aren't your everyday volcanoes. They're geologic titans hiding beneath the Earth's surface, building up unimaginable amounts of molten rock and gas over hundreds of thousands of years. The potential for an eruption exists, albeit it's a rare event. The last one occurred about 700,000 years ago. If such an event were to happen today, the global impact would be cataclysmic. The supervolcano would spew billions of tons of ash and sulfur dioxide into the atmosphere, blocking out sunlight and causing a significant drop in temperatures. This would disrupt climate patterns, lead to widespread crop failure, and potentially cause a famine. The eruption of a supervolcano could plunge the world into a volcanic winter, devastating ecosystems worldwide. Coming in at number 5 is the threat of a gamma-ray burst. Now you might be wondering, what exactly is a gamma-ray burst? Well, it's the most energetic form of light in the universe, typically produced by collapsing stars or the merger of neutron stars. They're cosmic flashes that can release more energy in 10 seconds than our sun will emit in its entire lifetime. Picture this: a star, light years away, dies a violent death, sending a beam of gamma rays shooting across the cosmos. If this beam were to hit Earth, the consequences could be dire. The intense radiation could strip away our planet's protective ozone layer, exposing all life to harmful ultraviolet light from the sun. Think of the ozone layer as Earth's sunscreen. Without it, our planet would be vulnerable to a surge of solar radiation, causing widespread damage to ecosystems and potentially leading to a mass extinction event. A gamma-ray burst aimed at Earth could strip away our planet's protective ozone layer, leading to a mass extinction event. At number 4, we have the potential threat of a rogue black hole. A black hole is a region of space where gravity pulls so much that not even light can escape its grasp. Now, imagine one of these cosmic nightmares on the move. That's a rogue black hole, untethered, wandering across the universe. These dark wanderers can be ejected from their home galaxies during violent collisions, sent hurtling through the cosmos at blistering speeds. As they journey, they can disrupt the celestial harmony, pulling stars, planets, and even other black holes into their deadly dance. Now, what if one came too close to Earth? The effects would be catastrophic. The gravitational pull would distort our planet's shape, causing massive earthquakes and tidal waves. As it gets closer, the black hole would start pulling Earth apart, eventually swallowing it whole. A close encounter with a rogue black hole could spell the end of our planet as we know it. Coming in at number 3 is the heat death of the universe. Now don't let the name fool you. This isn't about the universe catching fire or anything quite as dramatic. It's about cooling down, really, really cooling down. But let's take it from the top. To understand the concept of the heat death, we first need to talk about entropy. In simple terms, entropy is the measure of disorder in a system. According to the second law of thermodynamics, in a closed system such as our universe, entropy always increases. This means that over time, everything tends to move from order to disorder. Now you might be asking, what does this have to do with the universe cooling down? Well, everything actually. You see, as entropy increases, energy becomes more evenly distributed. This leads to a decrease in the differences in temperature across the universe. Now imagine this happening on a cosmic scale, over trillions and trillions of years. As stars exhaust their nuclear fuel, they'll fade away one by one. Galaxies will slowly darken as the last embers of starlight flicker out. The universe will become a cold, dark place, with temperatures approaching absolute zero. This is what we mean by the heat death, but it's not just about temperature. The heat death also implies a state of maximum entropy, where the universe reaches a state of equilibrium. In this state, no work can be done, and no new stars or galaxies can form. Everything just stops. So there you have it. The heat death isn't about the universe going out in a blaze of glory. It's about a slow, gradual fade into darkness, a final, silent curtain call. It's a reminder of the impermanence of everything, even the stars and galaxies that seem so timeless and eternal to us now. The heat death of the universe represents the ultimate end, not just of Earth, but of all stars and galaxies. At number 2, we have vacuum decay. Now this may sound like a problem with your household cleaning device, but I assure you it's far more intriguing and infinitely more terrifying. So what exactly is vacuum decay? In the grand theater of cosmic events, it's a showstopper, a phenomenon that could spell the abrupt end of our universe as we know it. Picture this. Our universe is filled with what we call the Higgs field. This field permeates all of space and gives particles their mass. It's sort of like an invisible ocean that we're all swimming in. But here's the catch. The Higgs field might not be in its lowest energy state. It could be in a false vacuum state, sort of like a ball sitting on a hill, ready to roll down at any moment. Now let's introduce the concept of vacuum decay. Imagine a tiny bubble forming in this Higgs field, a bubble of true vacuum, where the field has dropped to its lowest energy state. This bubble would not be a peaceful, harmless entity. Instead, it would expand at the speed of light, obliterating everything in its path. Frightening, isn't it? But it's also fascinating. This bubble of true vacuum would rewrite the laws of physics within its boundary. Particles inside it would lose their mass, causing atoms to disintegrate and effectively annihilating all matter. It's like a cosmic reset button. The best, or perhaps worst part? If vacuum decay were happening somewhere in the universe right now, we wouldn't even know it. The bubble's wall would be expanding at the speed of light, meaning we couldn't see it coming. One moment you're enjoying a cup of coffee, and the next, poof, everything's gone. If such an event were to occur, it would truly be the end of everything. But don't worry too much. The odds of vacuum decay happening are incredibly, incredibly small. So, for now, you can go back to your coffee in peace. And finally, at number 1, we have the Big Rip. This isn't your everyday cosmic event. The Big Rip is a hypothetical end-of-the-universe scenario. Now let's dive a little deeper into this phenomenon. Picture the universe. It's constantly expanding, right? But what if that expansion doesn't slow down or stop? What if it accelerates? Well, that's the premise of the Big Rip. As the universe expands, gravity becomes weaker, unable to keep matter together. Over time, this could lead to galaxies, stars, planets, and eventually even atoms themselves being torn apart. Imagine everything that ever was, is, and could be ripped into fundamental particles, scattered across the infinite cosmic canvas. No galaxies, no stars, no planets, no life. Just an endless sea of particles drifting in the vast expanse of nothingness. The Big Rip represents perhaps the most complete and final end possible, the end of all matter, everywhere. So there you have it, 8 scientifically plausible ways the world could end. From solar flares to the Big Rip, these phenomena captivate us with their scientific intrigue. While these scenarios may seem daunting, remember, understanding our universe and its potential ends only underscores the beauty and preciousness of our existence.